All right, hello physicists. In this video, I will show you how to complete the Resonance in Tube lab. So your goal today is to try to get a note from a tuning fork to resonate in a tube. And today we will use a PVC pipe as our tube. Now, normally a PVC pipe is open on both sides, but when we place it in a graduated cylinder with water, the water is going to seal off my tube, making it a closed tube. So when I place the entire PVC pipe in my graduated cylinder of water, even though the PVC pipe has not changed, the length that I am considering is from the top of the water to the top of the PVC pipe. And that is the value that we are going to call L. It's going to change based on top of the water to top of the pipe. Okay, so we are looking for a certain length that's going to allow a tuning fork to resonate. So to resonate means to get louder. So when we visualize a sound wave, in order to resonate, we need the antinode to line up exactly at the top of our PVC pipe. So when we have an antinode all the way at the end, that means we have a quarter of a wavelength that's fitting inside my tube. All right, now we cannot see the sound wave, so I cannot visualize where that quarter wavelength is, but when we listen, I should hear that when my note gets louder, that is when my antinode is aligned with the top of the pipe. So you're going to place your PVC pipe all the way into the water. Here I have a tuning fork. Let's start with this one. The note says it's an A, but next to it is a number, and that is the frequency in hertz. This one is 440 hertz. So to make your note, you have two options. You can strike it with the rubber part of the mallet, get a little note, or you can strike it against this rubber pad. Not the table, the rubber pad. So I'll place it, hit the rubber, and I hear a note. Okay? Very important to keep our tuning forks from getting damaged. You do not hit the table, you do not hit another tuning fork, and you definitely do not hit the person sitting next to you. Only rubber. Okay? So I will strike it against the rubber mat, and I hold it over the pipe. Make sure it doesn't touch the pipe, it's just directly over it. And I'm going to listen for when the note gets the loudest. As I'm listening, I'm going to lift the PVC pipe up, changing the length until it gets louder. So I'll try that now. Listen, listen. Ooh, and I don't know if you can hear it, but right there, with this particular length, I am getting resonance. So with my meter stick, I'm going to measure from the top of the water to top of the tube in meters. I see about, I think, 18.5 centimeters, so that would be 0.185 meters. And I want to document that in my notebook. So again, that tuning fork for me was 440 hertz. That was my L, my length of the tube. Okay, and remember that that length is equal to a quarter of the wavelength. I will document that in my notebook, and I will repeat with another tuning fork. So for example, here I have a G, and this one says, I think, 384 hertz. So again, I will strike it against rubber only, hold it over, lift the PVC pipe until I hear resonance. Oh, I think it's right there, but I'll try again. And for me, it's getting louder right there. So again, I will take my meter stick, I will measure from the top of the water, top of the PVC pipe. I have that as my L value. I will repeat this process a few times with a few different tuning forks. In the end, you're going to use the values that you have to try to find the speed of sound. So think, how can we find the speed of a wave? What information do I need? What information do I have? You're going to do your best to use your measurements to find that speed of sound. Then you'll compare it to what our accepted value is for speed of sound. So, good luck.